So you see my screen, right?
Yep, able to
Okay,
see.
so we'll start the chapter simple movements. So these are the major topics that we would be covering. That is central limit theorem, skewness, kurtosis, and we have few practice questions. So if I were to specify mainly, there can be question on skewness and kurtosis, but rest of the topics that we have in this reading are very important from foundation point of view. When I say foundation, it is foundation for your paper 4, that is valuation and risk models. So like from exam perspective, there cannot be a direct question apart from skewness and kurtosis. That's our view. But yeah, it serves as a very basic foundation for your paper 4. Let's start.
So you
Yeah.
said there won't be any direct question other than apart from positiveness, the skewness, correct?
Skewness and
According to
kurtosis,
kurtosis.
according
Okay,
to me. Yeah, that's
okay.
how like we when I think yesterday we spoke. That's what in fact I was referring to. We have exact alignment with the exam. So we will keep very filtered preparation
Mhm.
given you have a time constraint.
Yeah, okay.
So
Yes.
these are the all topics that we have in this learning. But as I said, that the main focus that we would have from exam perspective, it would be on the areas that were listed in the earlier slide. But yeah, this is the entire learning outcomes from this reading.
Okay.
So the main content before, like the very basic thing, why we have this big statistics and probability is the main objective is to understand the population from sample. So if I just talk about like in context of operational research, just to give you a better understanding, if a company wants to launch any product, it's not feasible for a company to conduct research for the entire country. So what they do, they try to come up with some samples, and they try to study the samples, and they make some decisions based on the population. So this is a basic thing that is the it's a basic idea about the major concepts that we have in the probability and statistics. So, and before we start, this is a formula for mean, I think
Yeah,
very
yeah,
well familiar with. So
sure.
when we talk about the population, it's capital N. And when we refer to a sample, it's small n, just from the convention point of view. And like when we talk about variance and standard deviation, see, this is a formula, but if I were to give you more intuition, which is mainly required in your paper 4. So when I talk about standard deviation or variance, so first of all, see, this is a relationship between your standard
So,
deviation variance.
sorry, one minute. The capital N and small n remind me. Capital
Yeah,
N is for the sample size.
it's for population.
Capital N is the population. That's the entire population, and the small n is the sample size.
Sample. Yeah, that's
I
correct.
understood. Okay, okay. Yeah, I forgot.
No problem. Yeah, and the variance. So when we talk about sigma square, it is a variance. When we just talk about, so this is a Greek letter. It is used for denoting two parameters.
Yep.
One is this is a variance.
Sigma square.
Yeah, and this is standard deviation.
Root of
Yeah.
variance. Yeah.
And when I talk about, so I'll just try to give you more insight about this term variance and standard deviation. See what essentially this formula is doing. It is trying to calculate the distance. So this mu is your mean,
Yeah.
and this xi is your data point.
Yep.
So what essentially it is doing, it is calculating distance of each data point from the mean.
Yeah, sure.
So if I
How
talk about
distributed they are, and the reason why we do the square is to make sure that we have the absolute number. Right?
perfect, yeah,
Essentially, what we are trying to do is how are the variables are distributed across around the mean.
That's correct.
So I think I
Absolutely.
understand this thing. So I'm quite
Perfect.
familiar
So
with standard deviation and variance. The reason why we do,
variance.
example, I want to have
Mm,
a mutual fund, right? So I want
mm,
to see like if the mean return is like 10 percentage,
mm,
but if I am an investor, what would be the standard deviation? So if it's too
right.
much of standard deviation, then it means that it's quite a risky fund.
Risky.
The
Perfect. Yeah.
standard deviation is low, then there is
Mm,
more predictable fund. So depending on my risk appetite, then I choose whether it's a whether I should go for higher standard deviation or this one. So I think I understand the concept of standard deviation
and
variance,
variance.
especially. Yeah.
Perfect. So we'll skip that. And this square, do you know why we have this square?
Yeah, it's because it can have both negative and positive value, right? For
Perfect.
example, like a -2 and +2, but still it's a variance around
Perfect.
the mean. So we want to make sure that, and also it's n-1 because we want to take away
Mean data point.
mean
Perfect.
data point. Yeah,
Perfect.
yeah,
Perfect. Perfect. Yeah, that because the distance would be zero at that point. And
exactly.
as you rightly said that
That's in my
negative and positive dispersion may offset each other. That's why we square it so that
yeah,
we have the proper picture of the dispersion. Perfect.
dispersion. Yeah.
Yeah. And yeah, as you rightly mentioned that when it comes to sample, we have n-1 because we want to ensure that because the distance of sample mean from sample mean is known, so
Mm.
that there is
The
no.
previous one is n, right? The previous one, when you have the entire population, then you go with
Yes,
n. And when you
yes,
have, what is the reason for the entire population go with n?
because
But
we do you don't have a or like when you see it's like I mean let's make it simple. When you can calculate the mean of the population, then you
mm,
can have n-1 over there also. But
mm,
when you are doing actually when we are trying to understand population from sample, I mean it's not able to count your entire population over
mm,
there. It would be like you will not know the mean of the population, right?
okay.
So that's the reason when it comes to population it's n, and when it's come to sample it's n-1.
We need to really make a note of it for the exam purpose.
Not really,
Not
absolutely
really.
not.
Yeah,
Yeah.
fine. Yeah, no problem. Because I'm very specific on one is the exam and second is applicability in the real life. Yeah,
Absolutely, I understand because of time constraint.
yeah.
Fine. So this is basically understanding the distribution of the sample mean.
Mm,
So suppose now, say for example, you have got data of 4 scientists. So there are 4 old scientists in the university, Jack, Andrew, Michelle, and Tom. These are their respective ages. And when we calculate the mean, so this is a mean. And when we talk about this population, so currently what I'm doing, I'm considering this as a population only because I know the entire, what is my entire set.
oh,
So this is my sample population mean, and this is my sample mean. And if I talk about distribution, when we talk about distribution, if
this
you
is the
recollect,
75 is the population mean,
yeah,
and the other one is the standard variance. No,
variance of
standard deviation or variance. This one
it's
is
standard deviation because it's
root is
sigma.
standard deviation. Yeah.
Yeah, it's just a sigma. Sigma stands for
So
standard deviation.
so here 78 minus 75 is 3. 3 square 9 plus 1 10.
Mm.
10 plus 9 18. 18 plus 1 is 19. 19 by 4.
Like
And
we have to square it, and
oh
yeah,
yeah, square fair. Yeah, square.
but
Yeah, okay.
see, from this point of view, your Calci, if you plug in all these sample, is just 4 data points in your financial calculator, it will directly give you this data point, this. So absolutely no need to worry about calculation. In fact, it gives you the correlation, everything
Oh
you
yeah.
can.
So we need to get this financial calculator for the
Yes.
exam.
Yeah,
Okay.
yeah, absolutely. You don't need to square it and do this
Wow.
all mess. So this
Mhm.
is perfectly fine. I mean, of course, it won't be asked in your exam, but yeah, if it all needed in your exam, you may
Mhm.
directly just substitute these 4 data points in your calci, get average and standard deviation.
Oh, okay. I didn't know that. I thought we are taking the normal calculator. Okay.
No, no, absolutely. I'll share one short YouTube shorts after this
Sure.
class. You can note down the steps from there.
Sure.
And when I talk about frequency distribution or probability distribution, if you recollect our school days, we used to get marks of the student and we used to make frequency table. So
Yep.
similar kind of stuff is here. So when I talk about Andrew, getting the Andrew's age, that is 78, has a probability. So out of this, what is the chance that I will pick up Andrew? I mean, I'll get a Andrew's age is or
One
Jack's
fourth.
age is
One
one
fourth.
fourth. So
Yeah.
this is a uniform distribution. So some part of this, so you can cover 2, 3 topics. I mean, at a time if you are smart enough. So this is a uniform distribution. So when I talk about uniform distribution, probability of getting each outcome is
Equal.
equal.
Equal. Okay,
So
just let me make a note.
yeah,
Uniform distribution is probability of getting each outcome is equal.
yeah.
1 second. Okay, got it.
And this is in absolute terms. So Andrew's age is 78. So somewhere, I think Andrew is here. It's 76. 76, Jack 78, Michelle 72, and Tom 74. So this is just a normal distribution. Now, next one is very interesting. Now, say for example, from this population, so
So
from
you
set
said
of,
normal distribution or uniform distribution?
see this one currently when I plot this distribution. So that's the basic. Now what I'm doing, I'm trying to create a foundation for central limit theorem. Of course,
Okay. Okay.
that is not a basic question. So one initially this population was uniformly distributed. When you talked
Mm,
about everyone, it had a probability of getting 25%. Now
mm,
when I'm drawing samples from this population, say there are 16 possible samples from this set of 4 people. So likewise, if I were to state all possible outcomes on vertical axis and horizontal, these are the set of 2 samples I can draw. I can have 78, 78, 78, 76. Likewise for all the other possibilities. So these are the sample size of 2 that I can plot from the given population. So, and if I calculate the mean of these samples. So say for example, if I calculate the mean of the 78, 78, it would be 78. And midpoint of, when I say mean, it's a midpoint, like in general, of course, median and mean has some difference. 76 and 78, it's 77. Likewise, all the way till 72. Uh, so far
mm.
good.
Yeah, only thing is like why we do this is the question. I think I understand the chart 2 by 2 matrix,
Yeah.
and we are getting the individual since we are doing the average, but a bit confused on why are we getting this
See what coming back to what I told you originally, like when we try to understand the population. So in this case, the population is quite small. Like we
yeah.
just have 4 samples, 4 elements in our population. But in practical world, you may have an entire country. Over there, it's feasible to have draw samples. Like you can say, just if country is not feasible, take a sample size as a state. And so idea is to get the mean of the states. So just imagine these as the state elements. And
So the question here is like since it's 4 we are doing this 2 x 2 table. If it's like 9 we'll do 3 x 3.
see, not really that. I mean, I
Okay.
can have sample size of 3 from all this also. So like in this case, how we had, so it was 2 to the power, like 16 is how much? So if I just talk about this, it's 2 to the power 4, because we have 4 elements and we are drawing it from the sample size of 2. So when it
Mm.
would be 3, it would be a 3 to the power 4. Like the how,
When
I
you
mean,
say
how,
3 3 some because we have got 4
mm,
samples, correct?
mm. So
Yeah,
four is no, elements in population. So
yeah,
if I
elements
were
in the mm.
if I were to take a sample size of 3, so instead of this small n equal to 2, if I were to go about small n is equal to 3, then
Oh,
it would be a big this set. So 3 threes are 9, 9 threes are 27. So how we had 16 pairs here, over
mm.
there we would have a 27 uh, samples, and we can have this 27 sample means. And
Okay.
how we had, now what we are trying to understand, earlier how we what we had, it was an actual element. So
Data. This is the
yeah,
actual data.
yeah,
Mm.
this is a mean distribution of the mean. So when I talk about 72, over here probability of getting 72, how many 72 are
I
there?
think it's
Only one.
only
So
one.
1 over 16, so it would be around, I think, imagine
0.05. Okay.
above, little above than 0.5. So
Okay.
likewise, this is a symmetrical distribution.
Essentially, this
70,
is a sample size. Essentially, what you're doing is a sample size.
it's a sample mean distribution.
Yeah,
These are
this is
sample
the
means.
chart is a sample mean distribution, but
Yes,
whatever we have seen there on the left hand side is a sample
yes,
total sample.
yes, that's correct.
So
This
we
is a,
mean to say that we are getting one like we are getting 2% of 78, 78 age, 76, 78 age, 74, 78 age, 72, 78 age. Is that correct? Is my reading of that first table on the left hand side, is that correct?
so till first point, it's a sample. Then what you said, can you repeat? I can
So we
recall it.
are we getting like when we take a sample size. So in this case, we have 16 samples, correct? We have 16 people, 16 samples we have. And
Yes,
if I take randomly randomly two items, the chance I'm getting it will be 78, 78.
yes, that's correct.
And 76 can be 76, 78. It can be 74, 78. So those
Yes,
can be the different samples.
that's correct. Absolutely. Yeah. So
Okay.
16 samples of size 2, because that's the
16 sam.
maximum. Yeah.
Hmm.
So these are 16 samples. So elements are 2. So one
Hmm.
sample has 2 elements. So if I increase the sample size, if I make
Hmm.
it 3, then the so the
27.
yeah, it would be 27. Like then you can have this different distribution, and it would be more like a normal distribution. Over here also you can see the symmetricalness. 72 and 78 has a similar probability, likewise 73 and 77,
Okay.
and 74 and 76 and 75 is a 25% probability, because that was, if you notice, a population mean. That's why it has a highest population.
So for me to understand better, it's essential that I understand that we are doing a cumulative distribution. I don't know, not cumulative distribution. We are doing a distribution of mean in the table, right? That's what we are doing. So all I need to understand is we are trying to distribute the means based on the probability of occurrence in the
Yes,
table
that's
down.
correct. That's correct.
That's it.
Yeah.
That's all I need to understand. So when I get a question of different means and other things, I need to look at how this mean would be, the different samples of the means would be distributed.
Perfect. That's correct. Absolutely.
Okay. Okay.
So the important point is, like, if you notice, the mean of sample is also 75.
Hmm.
Or if you calculate, I mean, if you calculate the mean of this 16 data point, it would be also 75.
So when you say
So
16, like 78 minus 75 square plus all those,
uh,
every all those.
that is variance. So when I talk about mean, over here I'm referring to mean.
Mean fine. I'm talking about the standard deviation
Standard
of
deviation is
1.5, 1.58. So what they've done is for all the 26, they have subtracted from
16.
the
All
mean,
16. Yeah.
16, sorry, 16, they've
Yeah.
subtracted from the mean
Yeah.
and then squared it, divided by the size, and then took a square root.
Yes, the 16 minus 1, that's 15. And yeah, I mean, some squared deviation divided by sample minus 1. That's the
Yeah. Okay. Got it.
idea. So, so that's calculation is fine. The important point is the population. Important point to notice, the both are same. I mean, population mean and sample mean are same. Important one is, not sure what's
Mm.
happening. Variance of population was this one, like it was, standard deviation was 2.236, and variance, if you square it, it would be approximately 5. And when I talk about sample, so if you notice that the important point that I'm trying to make, so if you try drawing samples out of population, your variance goes down. Like your, if you notice that it was 2.23, standard deviation was 2.23 in case of population. In case of sample, it's 1.5. So once you draw more samples from your population, your variance comes down. So it says your population variance, it is lower than your population variance. So variance of sample mean decreases with the increase in sample size. This is a only point that I am trying to make.
Sure.
So when you increase your population size, sample size, when you increase your n, basically sample size, that will decrease your variance. And
Understand.
this is the equation, and it is quite intuitive because n is in a denominator. So
Yep.
it, as you increase it, your sample variance will go down.
Okay.
And not just
So the
just
point here is more the data points, lesser the variance.
yes,
And one thing that I'm bit maybe bit primitive to ask. Usually the population size will be more than the sample size, correct?
population size. Yeah, that's correct.
Correct. But in our case, we just for the illustration, we took the population size as 4,
Yes,
but the sample we have made it as 16 or whatever it is,
yes,
right?
that's correct.
Just for illustration,
See,
correct?
in general also, your point is correct. But what we can do, if I just talk about say our country, if I just say I talk about 1 million.
Hmm.
Okay, say population. If I just talk about I want to study the demographics and the population of certain country is 1 million. But if I can create some samples out of it, say based on demographics, so on the from same sample of from same 1 million population, I can have the multiple categories which
Okay,
can be more than 1 million. That's
understand.
practically also possible.
Possible.
Yeah.
Different combinations, you can derive
Yes.
into different combinations and then increase the sample size.
Perfect. Yeah, that's
Okay,
correct.
understood.
And that, in
Understood.
fact, that is only recommended because that will bring your variance down. That will give you
Down,
a better
yeah.
understanding of
Instead of
population.
surveying, or for example, if you want to do an
Yes.
election report, instead of surveying all the 100 crores, you just take the population
Yes.
for I don't know, like 1 crore, and
Yeah.
then you enlarge the result to 100 crores or even
Correct.
150 crores,
Correct.
and then you get the okay, understood. Yeah,
Yeah.
got the
Yeah.
point.
And these are just terminologies you need to understand. So when we talk about point estimate, it's a single sample value,
Hmm.
say mean or some mean or variance to estimate the population parameter. Okay,
Mhm.
so as point estimate is you can just think of mean and variance, and the formulas that we used are estimators. I mean, absolutely no relevant with your exam, but yeah, you just need to understand what is a point estimate. It's a sample value. It can be mean or variance. That's the only thing that we are trying to from this slide.
Mhm. Okay.
And this is just the property your estimator should have when you are trying to estimate mean of population from sample. It should be linear. When I say linear, I should be able to linearly regress.
Extrapolate.
Yeah,
Extrapolate.
correct,
Y equal
correct.
to fx or whatever it is.
Y equal to mx plus c or anything.
Yeah,
Yeah.
yeah, yeah, yeah. Okay.
Unbiased is it should be it shouldn't be a bias. So if I try to like say estimate for some other parameter, say if I estimated the mean, and if I'm
Yep.
using that mean for
Then
calculation of variance,
understand.
it
Same
should be,
weightage.
yeah,
Same
that's
weightage. Yeah.
yeah. And consistent, it should be applicable
Can,
for
can you
large.
just give me a minute? Sorry, just give me a minute.
Sure, sure. Take your time. Yeah.
Hello, sorry. Um, so this is desirable estimator properties. Can you just go back a minute on the estimator means what estimator means? I've kind of a bit
Sure.
lost.
No
The
problem.
estimator point estimates. Okay. So this estimator is what is the sample parameters? It means rock on about two population parameters. So these estimators are the one which extrapolate your sample to the population level.
That's correct. Absolutely.
Oh,
Yeah.
okay. Just give me
Yeah.
a minute. Let me note it down. So these are some values,
Yeah. I mean, these are, you can just think of
formulas,
movements.
formula.
Yeah, movements of central movements that I would be covering in new slides. So when I say central movements, we have four central movements. Mean, variance that we have already covered. Next are skewness and kurtosis. So these are the parameters that you can think of sample to population.
Yeah, sample to population. Got it. And what are the different attributes? Like they should be the next slide talks about the non-biased and then linear, all those things, consistent. Okay, I think I
Yeah,
understand that.
yeah. And so yeah, this, I mean, if any estimator has these property, linear unbiased estimator, so we call it as a best linear unbiased estimator. That's
Okay.
just a terminology, no absolutely question or I mean in context. And central limit theorem, I think I already demonstrated when we were talking
Can you
about
just go back? Best linear unbiased estimator, right?
yeah.
Unbiased estimator. Okay.
With I mean if your estimator has got these properties, then you can tag that estimator as a best linear unbiased estimator.
Okay.
And central limit theorem, I think I already demonstrated when I was covering that example of scientist A's, but I'll just read it for you. For any population with mean mu and variance sigma square, the size of random sample gets larger, like we drawn two samples. But if you go a little more, three, the distribution of sample mean approaches to the population mean.
Okay. Just give me a minute.
Yeah.
With the increase in size of the sample, the distribution of the sample mean approaches a normal distribution.
So like how we had 16, if you go beyond 16,
So the
that
normal distribution is you have that minus 90 plus 90. I forgot that. Is that the one where your mean, where your standard variance plus one standard variance, or on both sides it's what do you call symmetrical?
see if I were to test if my
The
distribution is
bell,
so
the bell
yeah,
curve.
bell curve, but if I were to just test if it is like if I am given some data, I'll just share one blog after this class. You can just go through that. It will help you a lot understanding. So if I were to test if I'm just given a data, I don't have a pictorial representation of that. And if I want to test that if that distribution is normal distribution, the best way to do is that you calculate the standard deviation
Hmm.
and mean. So you have mean and standard deviation. So
Hmm.
this is like
1 sigma,
one
2 sigma.
standard deviation.
Hmm.
So like if I calculate this is a one standard deviation below your mean, and this is one standard deviation above your mean. So you just check if your population, the population that you have, I
Hmm.
mean how much percentage of population you have between in this area. So
Okay.
like if this is a 68%,
Yeah.
then high chances that your distribution is normal. Of course,
Normal.
I mean, just to state properly with confidence, you can calculate two standard deviation also and three standard deviation. For two standard deviation, if I recollect correctly, that's 95%,
95.
and
Yeah.
three
3 is
standard deviation, it's
90.
99%.
Yeah. Yeah. Okay.
So most of the your data lies within three standard deviations, so in normal distribution.
Hmm.
This allows us
Okay.
to, yeah, this allows us to make infer about to construct confidence interval. So when we talk about confidence interval, it's your mu plus minus sigma, and it is mostly used in your hypothesis testing. So that's a confidence interval. I mean, it's quite important in your hypothesis testing chapter. So you
Mhm.
can just make a note of it. It is like just same thing. If someone is asking you build 95% confidence interval, then
Okay.
you will take this z. So sigma z, actually this z
Hmm.
is representation of how many standard deviation you are far from the mean. So in
Okay.
this case it was 1 because we wanted 68%, but when it comes to 95% population,
3.
so it could be 2 sigma z, 2 sigma, 3 sigma z, based on how much confidence you are given. So if I want to state something with 90% confidence, this Z value will be different. If I were to state something with 99% confidence, then this Z value will be different. So Z value is a representation of that confidence level. And
Okay.
based on this confidence level, you build a confidence interval.
Okay. So ZS value represents the confidence interval, confidence level,
Confidence level, absolutely. And if I were
95
to,
percentage and other things, right?
yeah, and it what it tells you exactly, Z value tells you how many standard deviations you are far from the mean. So
Mean
if Z value is 1, then
68 percentage, right?
yes, the Z value is 1. That means you are one
One
standard
standard
deviation away
deviation.
from the mean. If
one
Z
standard,
value is 2, then means you are two
two
standard
standard
deviation away from the mean. That's
deviation.
the interpretation of Z value.
So how Z value represents tells how far from
You
the
are away
mean, right?
from the center point, center or the mean.
Okay.
Okay. And this one skewness, it's a third moment. When we talk about third moment, can you help me
Uh,
reminding?
1 second. So when we talk about the central limit theorem, it just says that when increase in size, the accuracy increases or the deviance decreases, the variation decreases, right?
In general,
And
in general,
approaches now.
yeah, in general, yes, what you're saying is correct. But if you're talking to some stats guy,
It
how
said,
you can, yeah,
yeah, sample approaches a normal distribution is what
sample
we should be
mean,
using.
sample mean
Sample mean,
distribution,
sample
sample
mean,
mean distribution reach out to normal
normal
distribution.
distribution. And
That's
the
the, yeah,
yeah, that's a terminology. But in terms of exam, will I get anything on the central limit theorem?
absolutely not. But it's a quite interesting area wherein interviewers script
Oh,
a lot. So
okay,
that's why
okay,
I was
fine,
emphasizing.
fine, no
Yeah.
problem. Yeah, yeah.
Exam point of view, this is something which is so mean and variance understanding you will need in your paper 4. Now from
Ah,
this chapter, these are the areas wherein your lot of questions are asked.
mm.
So when I talk about sigma square, can you help me reminding the formula? So I'm referring to variance.
Sigma squared is
Simple. Yeah,
you have your sigma I equal to 1 to x and xi minus mu the whole square, right? That's your sigma. That's your sigma square. Yeah, xi minus mu the whole square. Sigma I equal to 1 to x and
yeah.
then divided by n. So
N
that gives
minus
you,
one or
yeah,
n, yeah.
n minus 1.
Based
That
on the
gives you a
sample
sigma
or
square.
yeah,
So here we need to get the data points and we need to get the mean. If we get the mean and other things and the data points, then we should be able to get the sigma square.
that's correct.
That's a variance.
So now this is called as a second movement of the mean. So now if I talk about third movement is called as a skewness. So if I were to see what variance tells you how much your data is dispersed, but if I want to understand how, I mean, where in the most of your data lies, or if there is a skewness. So when I say skewness, this is how your data looks like. So if it is a right skewed, your data should will be mostly your distribution will look like this,
On the
slightly
tail.
right skewed. So
Mm.
we have the heavy light tail, but if I were to measure it, like if I were to have some formula like this, so it is like third moment.
Just give me a minute. Measures the degree, measures the degree to which, yeah, I think yesterday I studied this. So the formula of instead of square, it is 3. And the last one is instead of 3, it's 4.
Absolutely, yeah.
Yeah,
But and so when I talk about skew, measure the degree to which your distribution lacks symmetry. So currently, if I talk about normal distribution, it is symmetric from
yeah,
both sides. So when I talk about skewness, it measures by how much degree your distribution is lacking a symmetry.
okay.
So if it is not symmetric, how much it is not symmetric, that is measured by your skewness.
Yeah. So
Uh,
skewness is on the tail.
Yes,
How much of these are on the tail side? So tail means it has maybe increased risk.
yes,
Many
that's
items
correct.
in the tail, that means that it has got increased risk. That's the skewness, right? That's applicability point of view.
Yes, absolutely. In fact, when we have one good question, we will you will not apply it over there. So for a symmetrical distribution, skewness is 0 because it's absolutely symmetrical. There is no skewness. Mean, median, mode is equal.
Equal.
So when I, yeah,
1 minute low measure to which distribution lacks symmetry. And for symmetrical, when you say symmetrical, it's your normal distribution, correct?
that's correct. Yeah,
For symmetrical distribution, the skewness is 0. Yeah, I mean, it's quite common sense, but let me note it down. Okay.
sure, sure.
Yeah, sure. Yeah, I think I understand the skewness part.
So positive, and when we talk about positive skewness, it is equal to right skewed.
Yeah,
So like your tail is on the right hand side,
yeah.
and very important to notice when your tail is on right hand side, your mean that is center gets shifted towards it. I mean, in
Right.
general, Yeah, very important point. In general, in whichever side your tails lie, your mean gets shifted to that. So
Got
if
it.
I talk about left tail, then your mean would shifted to the on the left side. But yeah, the property of median is always between mean and mode.
Mm.
Okay.
Okay.
So and in the same way, we can talk about a left tail where your mean gets shifted to the left tail, and the median is already at the middle, and your mode is at the right side.
Got it.
Yeah,
This is clear.
yeah, and this is a kurtosis.
Photos. This is
So
the one I was talking about, the power four, right? And this is about
powerful
distribution within the median, mean distribution within the mean. Is that right?
distribution within the mean. Can you?
Around the mean, around the mean.
Yes, that's correct. I mean, yeah, intuitively, it is the answer to your question is yes, absolutely.
Mm.
And so, see, there is a lot of confusion. Like if you go to Google, most of the times you're like it is inferred. Kurtosis is inferred as a uh, like this peakness. In a way, it's true, but if I were to technically talk about it, it's really mainly on the this thing tails. So when I
Oh.
talk about
Mm.
yeah, just make a very important note of this. So technically, it is like if you have got usually like how we had skewness is 0. So kurtosis for a normal distribution is 3.
Mm.
Okay. And for the ones which are, I mean, less peaked, it has a kurtosis of -3. So like there are two terms. Okay. So kurtosis and excess kurtosis. So when you say excess kurtosis, it is
How
like
is kurtosis for normal distribution is three? How do you say it's three?
like how you interpret one standard deviation would have 68% data.
Yeah.
From that, it is calculated or there would be some theorem based on which it is interpreted that kurtosis of normal distribution is 3. You can take any normal distributed data and try to calculate it would be near to 3. I mean, when you talk about practically, but when we talk about generic things from the way the normal distribution has, like it's
Mm.
one standard deviation, 68%. From that, it has been derived that kurtosis of normal distribution is 3.
Mm. Okay.
It is not part of this, but yeah, if you're interested, I can get some literature for that, but
No
absolutely
problem.
not required
No.
in
Okay.
context of exam. And like there are two terms, make a note of it. One is kurtosis and excess kurtosis. So when you say kurtosis 3, excess kurtosis -3. So excess kurtosis is,
Excess kurtosis is -3. Yeah.
yes, it is like whatever kurtosis your distribution is, subtract that from 3. So say, let me call it as small k. I mean, you say, for example, you calculate it from your data, subtract 3 from this data, that will give you a normal this thing excess kurtosis. So excess kurtosis is -3 for this thing. Let just
So it's always zero excess kurtosis.
yes, for see, for excess kurtosis for normal
Normal
distribution
distribution. Yeah.
is
Mm.
0. But if you
Zero.
have got say less peak, there would be say if I talk about meso. So there are three terms: mesocortic, platycortic, and leptocortic. So mesocortic is something that we talked about here, normal distribution.
Okay.
Mesocortic has a excess kurtosis as 0. And when we have say something thinner with some distribution with a thinner tails, say I have got kurtosis as 5.
Mm.
So excess kurtosis would be 2. So how much above 3? So 3 is a benchmark for a normal distribution. If I'm referring to some distribution which is leptokurtic, that has a thinner tails. So how much it has a access to normal distribution, that is 2. The
Okay.
absolute
I don't know
kurtosis
whether I
is
need
5.
to remember the leptokurtic, but as long as I remember fatter tail and then the thinner tail, kurtosis is.
Unfortunately, this,
Oh,
I mean, you need to remember. So how,
because
I
when I
mean,
read it in the, I don't see this leptokurtic and platycortic in the Kaplan. I read it yesterday evening. I don't remember
okay,
seeing this. Okay, so should I?
ideally it
Oh, okay.
should be there. I would imagine.
Is it
I
okay?
mean,
Okay, because I was going through very fast, honestly, yesterday on these things because
mm.
Maybe I would have missed out. Okay.
Yeah, I would imagine it should be there, but let me just check. I mean 99% I'm sure it should be there, but it's not there then. But you should remember, because yeah, these are
Hmm.
the usually terminologies used for excess kurtosis or thinner tails
Yep.
in term context of kurtosis. So just remember LMP in that way. So
Okay.
L leptokurtic, mesokurtic, and platykurtic.
Okay. Right. Oh no, I was talking about the kurtosis was there. What I'm saying is about the leptokurtic and platykurtic. I don't remember seeing that.
Sorry, can you say that again?
No, what I'm saying is this leptokurtic and platykurtic, right? I
Hmm.
don't remember seeing that in the Kaplan. I remember kurtosis, but I don't see
Hmm.
remember this. Okay, high
Yeah.
they say just say fat-tailed and they just say fat-tailed and thinner tail. That's it. They didn't give the name. Okay, that's
Uh,
anyway.
yeah, but just make a note of it. Fatter tails. The the ones which has quite fatter tails is called as a leptokurtic.
Lepto. Hmm.
Yeah,
Okay,
and one which has a thinner tails is called as a
platy.
platykurtic, and the this normal distribution is mesokurtic.
Okay,
Yeah,
platy. Okay, okay, fine.
yeah. And this is a covariance. It's just like measure of how much two variables move together. So, and this is a formula compute each data point distance from mean. Take a product of this deviation
Oh,
divided
this
by
is can you go slow on this? This is something that I couldn't understand yesterday, I believe.
no
The
problem.
covariance.
So covariance, see, variance is something when you have one variable, say only ages that we talked about. Okay. So like we had age of 72, 75, 76, and 76. So in this context, I can just talk about variance.
Hmm.
But when I have two variables, I can talk about covariance also, like
Hmm.
how much degree they are moving together is something measured by covariance.
Okay.
Okay, and the method is quite similar to how we calculated variance. But what you can do, you can just calculate the deviation of every data point for x variable from mean,
Hmm.
and you can do same for y variable also, and take a product, sum it up, divide by n minus 1. So when you take a product, because we want to understand why we are not squaring it, because actually we want to understand if variables are moving in same direction or different opposite direction. That's why we are not squaring it here, but the product, we are taking a multiplication, summing it up, and dividing it by n minus 1. So this is an example that we have two stocks, their returns. Their mean is 5% and 7% respectively for stock 1 and stock 2. And these two columns are deviation from this mean, respective means. And this
So
is a
year one, the stock gives 5%, stock two gives 7%,
mm,
and negative return, and then another 12% and 18 percentage return.
mm.
So these are the returns. Now, how do we calculate the covariances? RT minus R1. So how do you take? Okay, so you take the first year as a benchmark.
So for stock 1, can you tell me what would be a 3-year mean for if these are your returns for 3 years?
Oh,
Can you
okay,
tell me what is
okay.
the mean? So this
So it's
5% is your mean.
point 0.15. 0.15 by 3 is equal to 0.05. The second one is 0.25 minus 0.04, 0.1, yeah, 0.07. That's right. Okay.
So this is
So
a
here, I think it's kind of the first year become a mean in both the cases, both the stocks,
yes, you can say that.
coincidentally.
Yeah.
Okay. Yeah. Okay.
So that's why the difference
That's why
of
I got
their
confused. If you have
okay.
given another example with the mean
I
not
see.
exactly become the year number one, right? Then
So this
okay.
is something R bar, I would say. It is coming from here. And
Yeah.
this RT2 bar is coming from here. This one.
So RT is what? RT is the mean.
Oh, it's like you can say R bar. Like this is the correct way. R2 bar. I would say R2 bar. You can just say this RT is R2 bar and
Okay.
this RT is R1 bar. So these are
Okay.
how calculated and substituted, and covariance is calculated.
So R1 bar, R2 bar is the mean, and current return minus mean, current return
Yes,
minus mean. And
absolutely.
what you do is you divide both to calculate the covariance.
First, what you can do, you can multiply these deviations. So 0
Mm.
into 0, 0, multiplication of these two
Oh,
numbers,
it's not.
negative
Oh,
and
sorry. It's a okay. It's not a. Sorry. It's not a division. Okay. It's a multiplication.
yeah, it's
Okay.
multiplication, and then you divide it by n minus 1. That will give you
Okay. That will give the
a
covariance.
covariance. Yeah. But
Oh.
yeah, no need to worry. This is directly, again, as I said, you can get from your calculator directly. So absolutely no
So
issues.
what
There
do you
are
need? What I need to input is the
these
mean
things. Oh no, these things. Uh, the 5% minus 2% and 12%, 7% minus 4% and 18%. You just substitute these two data sets in your calci. You will get everything about these.
covariance. You get the covariance directly.
Yeah, you get covariance, but see, to be honest, in a practical world, covariance is not that of use. That's why we have got correlation. So we usually talk about correlation, not covariance. So from calculation perspective, because see, if I were to look at this number 0.000777, it doesn't give me much information about how in a decision making. So
Okay.
that's why there is one more measure called as a correlation,
So sorry,
which
sorry, 1 minute. So if you want for the exam, I think I understand for correlation covariance is required.
yeah,
That's why you're teaching this.
yeah,
But in order to get the covariance, all I need to input in the calculator is the six values. Stock code
that's
number 1, 3, stock number 2, then it gives the covariance directly. Okay. And then I
absolutely,
need to feed that into the, so I don't need to remember this. I'm trying to see how fast I can learn. I don't need
absolutely.
to
Just
remember.
ignore. Yeah, yeah,
I
absolutely.
don't
Let's
need to.
just
Okay. Okay.
This is
Okay.
just for information. A
So
formula is not
covariance is
required.
how two stocks or
Move together
move
in
together.
same or different
Example,
direction.
example is usually people say SBI and ICICI, right?
Yes,
What is the
that's correct.
covariance, public versus private bank? Okay,
Absolutely,
oh,
yeah.
got it. Okay, okay. So next
So
is
sample covariance. So like slight, yeah, this is something which you should know, like in context of course, not from the calculation point of view, but when I see in this case, we were given the actual returns. But say for example, in instead of this actual value, I'm give so be very attentive now. So if I talk about this 5%,
mhm,
negative 2%, when I'm calculating mean, I'm just adding these up and dividing it by 3.
correct.
So what I'm presuming that probability of getting 5 to minus 2 and 12% is equal. But what if I give you some more information for 0.05, there is some probability, say 30%,
Mm,
and for minus 2%,
mm,
say there is some other probability, say 40%, and
mm,
remaining probability is for 12%. So in this case, like the your probability is not equal. When your probability is equal, you can just divide by n and get your mean and
yeah,
everything. But what if your probability is not clear in that term?
weighted,
Oh
weighted,
yeah,
right? So you multiply it and then you
yes. What you
mm,
can do in that context, you can how your mean would be calculated. You will take multiplication of these two. So this
yep.
is your x and this is your probability of x.
Mm.
So how you can calculate expected value of x? I think there is some issue with my dashboard, but yeah, manageable. Summation of
All the x times p probability of x.
xy. So this is how your expected value is calculated. But yeah, rest of the calculation is same. You calculate the deviation. So only
Can you
changes
just go back? Sorry, can you? So expected value of x is the mean here.
expected value of x is summation of PIXI. When I say
Correct. So
PIXI,
the point
30% times
30% of 0.05 and
yeah
40% of 2% minus and 30% of 0.12.
12%.
So you
Yeah,
get a number. That number is what? That number is
that
the
number is expected value or a mean. So when
mean.
you
That's what I'm saying. That would be the
mean
presumed mean, right?
mean, yeah.
Right now, these are probably they have the data with the assumption of probability is equal to 1.
Like
Correct. So if the
probability is not really one is for all outcomes, but yeah, for
yeah,
getting
right now
5%.
The table
Why?
says that the probability of getting 0.05 is 100%, 0.02 is 100, 0.1 is 100%. But if you have probability of less than 1, then we need to multiply that probability with the actual number and then do a summation. That will give me the mean. Is it correct?
Like in a way you are close, but I would say probability of getting 5% is not 100%. It's 1/3. That's why what you do when you sum these up,
You
5%.
divide by 3.
Yeah, that's right. The likelihood of getting 5% minus 2%
Minus
and your
2%.
12% is 1/3. That's why, like in this case, just the denominator is same. That's why in
3.
this case, like denominator is different for 5%, 2%, 12%. That's why you LCM and other stuff comes in the picture. In this, the denominator is 1/3. So I would say 5% getting probably 5% is 33%, not 100%. That's the only difference. Rest of your statement
Ah,
was correct.
you are right. Yeah, yeah. Right. The over, because it's 100 split across equally across 3. Here the 100 is split across as
Different
into
5%
different
differently.
5%.
Yeah, yeah.
Yeah. Okay. And that's why we are dividing it by 3 here. There we don't divide by 3, but with the actual number directly.
Yes, absolutely. Like in 40%, it would be like 4/10. That
Understood.
would
Understood.
be 2 by
I think it's
5.
very
So
clear. Very clear. Yeah.
2 by, yeah. So that's how, and again, rest of the method is same. What you do, you calculate difference of data point from the expected value, like X summation of Xi Pi. In this case, summation of Pi Yi. But yeah, what you have to do again, you have to calculate the expected value of the product. So expected value of this product. In this
But
case, you
this,
calculated deviation.
sorry, this is kind of confusing. So here for covariance, what we do, covariance of these two, right? Covariance of X and Y, same
Uh,
item.
if you had time, can we do? I mean, see, of course, this is absolutely not required. But yeah, I mean, this formula. I mean, you should get familiar yourself because
Oh,
sometimes it's confusing. So if you want, we can solve this problem. I mean, if
yeah,
you're
we can
interested.
do. Yeah, we
Okay.
can do. So this covariance of X and Y, correct?
Yeah, in this case, I will just take some. I mean, I'll generate some probabilities for this set also, and we can calculate covariance of, or I mean, using this.
Okay.
So let me just write it down here. So if I talk about x over here, it's p of x, y, p of y, and you are asked to calculate the covariance. So if I go back 5%.
But sorry, but you said that this is not from the exam perspective. As long as we understand this
Yeah,
one,
but
we should be okay,
yes,
right?
yeah, we
But
should
do
be
we need
okay.
to really understand, or should we go to the
No,
coefficient?
absolutely. If you just this E, just remember, if you understand this E only, then it's fine. Over there also, if you remember, just let me give you a very high level, given you are already experienced. So instead of going mechanically, let me
Hmm.
give you very high level statement. So if you focus like how we had divide by 3, we have something divided by n minus 1 over here also after getting a product. So in similar way, after getting product over here also, we had to calculate the expected value.
Yep.
So instead of n minus 1, we had to attach respective probabilities of x and y, like how we had there. So and get the covariance. So like in this case also it was 1/3. That's why we had one denominator. In this case also it's n minus 1, but we have to get the expected value of this product. What is
Okay.
the expected value of this product of dispersion of x and y from their mean? Does it make
Hmm.
sense?
Last line alone, can you repeat?
Yeah. So you need to calculate the expected value of the product of respective deviation of x and y.
Hmm.
Let me just write if that
X
helps.
and I think I understand. X and deviation of X and Y from the mean, from the respective mean.
Yeah, expected value of
Understood. Expected value of the two variables.
product of deviations.
Product of do. Okay. Understood.
You can
Understood.
just make a note of it, then it should be
Sure.
okay.
So covariance of X comma Y is equal to expected value of, just a minute, expected value of product of deviation from mean.
Yeah.
Okay. Covariance of x comma y is equal to E of x minus Ex. Ex is the mean times into y minus Ey. Okay.
Yeah. So this is just for your understanding. I mean, of course, it will not need it, but yeah, I mean, even FRM student, I mean, you should know. This is the most important. This you need to
Correlation.
understand and remember. Of course, this again, it is given by your calculator directly.
Sorry, one
No,
minute. When you say expected value, right? Can you go back there?
sure.
So when you say here expected value, so that E is that 1/3 on so covariant of xy is equal to, so I know, understand the x minus ex. So x is
Mm,
here in that
mm,
case,
mm.
every year you will have a zero 0.5 minus 0.5 times whatever it is. So so how do you calculate that E of, do you understand my question?
Yes. See, what would be happen that like how this you would be given this set data set
Mm-hmm.
under X, getting 5% probability is 30%. Similar set would be given for Y also, like stock 2 and P
Mm-hmm.
of Y. So, and the third thing that you would be given is if this 5% and this 3%,
Mm.
or I mean, there would be some getting, there would be some probability, say 20%. So, and the third column would be given what would be X 5% and Y 3%. There would be some probability of getting this also.
Okay.
So once you have probability respective deviations, you
Mm.
can have use this probability of first year, like first year 5%, X is 30%, Y 30%, 3%, and probability of Y 20%. What is the probability of getting 5% and Y 3%? There would be some probability given to you. You
Okay.
can use that probability when you are multiplying with the deviation. So this
Okay.
1/3 would be, so these are deviations. So this
Mm.
is a deviation of X from mean. This is a deviation from Y, I mean, for Y variable for first data point. And this is a probability of getting X as, say in our example, X is 5% and Y is 3%. Probability of that is something, in this case, it's 33%. It could be different also in real
Okay.
life.
Okay.
Yeah. And this is a correlation, like it's covariance divided by variance of X, Y both. So this is
Oh,
how your correlation is calculated. And it's a very important thing. It's a
mhm.
linear relationship between two variables.
Okay.
Yeah.
Correlation is shim between two variables. Correlation of uh, x comma y is equal to covariance of x comma y, which is given by the calculator,
Yeah.
divided by standard deviation, right? Standard deviation of x
Yeah.
and standard deviation of y.
Y.
Okay. Hmm. Standard deviation of x and standard deviation of y, as long as we input the numbers, it will calculate the mean, it will calculate the standard deviation, it will provide us, right?
Yeah, that's correct.
So even the correlation will be given by the calculator, or we need to calculate the covariance and then divide by the
So
standard
you
deviation of
you will you will directly get a correlation. I
also
think.
in the
Yeah,
in
yeah.
the
In fact, this is 100% sure about covariance, because usually it is not asked to calculate. Usually this is something which is actually needed for your
oh
calculations or everything.
correlation the calculator won't give. We need to do it.
Correlation, it will give you. Covariance is also there, but let me have a look. I'll
Sure,
confirm,
sure, no problem. Mm,
because usually we don't use covariance that much. That's why,
mm.
I mean, I haven't checked, but yeah, I'm 99% it would be there, and followed by correlation is 100% sure. It's
For
there.
correlations there, then why should we remember the formula? We
Yeah,
still need
in
to
fact,
know.
if say for example, just assume for a second, if covariance is not there, still we should be fine, because you get correlation
Mhm. Yeah,
and these
yeah.
quantities as well. You can just multiply and get it
Multiply and
also.
then get it
Worst
also.
case, not
Mm,
there, but it would be
okay.
there, because I think
For exam perspective, still I don't. I mean, anyway, I got remembered now. Correlation equal to covariance by the
this you have to
covariation of the
remember.
two by. Oh, we
Most
need to
important.
remember. Huh?
Yeah,
Okay.
this formula, because sometimes in your VAR also it is needed. Yes,
Where in where?
in valuation and risk models.
Oh, VAR. Okay.
Yeah,
Valuation at risk models. Okay.
yeah.
Got it. Yeah, they ask about confidence level. I don't know about the correlation. Okay. Anyway. Yeah. Okay. Okay.
So this was
Fine.
about, these are properties. So correlation measures.
Correlation measures the correlation measures strength of relationship. Correlation no units. Values from my +1 perfect per correlation -1 negative. Causality cannot be assumed. Correlation between the variables is high. Causality cannot be assumed. Okay.
You can just ignore this point, not really of that important, but yeah, most important one is this linear relationship. And it ideally you should get question that what about non-linear, I mean things that are not linearly related. Say for example, I have got two variables, then how do I estimate the correlation for that? That kind of practical things, I mean, ideally, what should think of. So we have other two types of correlations also. I'm not sure if earlier that was long. I mean, if I talk about few years back, that was a part of level 2. Now they have included in this. Over there, you need to calculate these like correlation types. So I'm not sure which chapter it is, but yeah, there are two types of more correlation. This one is Pearson correlation.
Mm.
Other ones that are used for non, I mean, any kind of variables, like not necessarily linear related variables. It is Spearman and Kendall tau. So those
Okay.
are something which are used for calculating the correlation for those variables.
Okay.
And this is something which you can just understand. Like over there, it's complete linear relationship. So there is a correlation of 1, that is 100%. Like if your x is also moving, x is moving by 2, y is also moving by 2. So we say that correlation is 100%. So if, say for example, if your x is increasing by 1 unit, so y decreases by 0.7. That's why we say that, I mean, it's a negative
So they
correlation.
also call gamma, right? In the I studied somewhere gamma.
Gamma is something,
When the
second
stock
option B.
increases by when your stock increases by for example index increases by uh, positive, then if the correlation is 0.7, it means that it is increasing by 70 percentage and decreasing by 70 percentage as well.
Yeah. Can you tell me, your engineering was computer science? Do you know difference between like s- velocity and acceleration? Just, I mean, I'm sorry,
Yeah,
I'm
it's about the direction, right?
uh
Velocity is the direction. I forgot the one is the vector and scalar.
yeah,
I
that is a
think the
speed and velocity. But when I say
velocity
velocity
and
is
acceleration is
acceleration.
per second. Acceleration is velocity per second, isn't it?
So let me just write the units. So for unit for this is meter per second,
Yeah, meter per second.
and acceleration is meter per second square.
Square. Yeah,
So what essentially acceleration is measuring how your velocity is changing by time. So
by time.
that's the acceleration. So similarly, if I talk about delta,
Mm,
delta measures your change in option price over change in spot price.
got it.
Okay. So similarly, what gamma is how your delta changes,
With time,
change
huh?
rate of change of delta with spot.
Or with
So again,
spot.
it would be like, yeah, it is with respect to spot. Like it's second order derivative. In
Got it.
nutshell, that's what I'm trying to say. Like
Understood.
how acceleration is like second, I mean, how your velocity is changing.
Perfect.
Over there, I'm trying to estimate how my delta changes with. So like gamma is like, I would say delta is also, again, if I put price, delta P by delta S. Let me
Mm,
just
mm,
let me just make it how your delta changes when your spot changes. So if I put delta's value, so it would be delta P by delta S divided by your delta S.
mm.
It is essentially how your price changes, delta P by how your price changes with respect to change in delta.
Got it.
So second order derivative in a nutshell. So
Got it.
that's the gamma, slightly valuation and risk model,
Different.
paper 4,
Mm,
Greeks, I think, end readings, paper 4. And this is a zero correlation. and negative correlation. This
Zero
data is
correlation. How do they say zero correlation?
like there
Because
is no
there's no
linear
pattern.
correlation. Linear correlation, yeah, there is no pattern. You cannot fit this into a straight line. That's
Yeah.
the interpretation.
Here it's -7 because I said x increases more or less, y
It's
decreases.
like you can fit this in this line,
Yeah, as x increases.
and over here
Okay,
you can fit in this line. So like this is a
uh,
increasing trend, and this is a
understood.
decreasing trend.
Got it. Yeah, yeah. Positive slope, negative slope. Got it.
Perfect. Yeah, perfect. Yeah. So now we come to end of this chapter. Like now we have some readings, practice questions.
Mm.
So this is something which will test your understanding because
Sure.
application is something which is more important. So analysis concerned with the symmetry and peakness of the distribution. So like we are talking about symmetry, it's skewness. For sake of understanding, let's understand peakness or the kurtosis of the
Kurtosis.
distribution of return over period of time for a company she is examining. She does some calculation and finds the median return is 4.2%. So
Okay.
median is given, mean return is 4.8%.
Okay.
So mean, median, and mode is given.
Okay. 4.8.
She also finds the
4.2. Sorry, 1 minute. One is 4.2. Another one is okay. Uh, Mode is mode. Then you have the median. Then you have the mean. Okay.
yeah,
Strange. All right. Fine. Fine. Okay. Got it.
yeah. So and she also calculate excess kurtosis is 2.
Hmm.
Based on this information, correct this characterization of the distribution on the return. Now see two things. First of all, let's evaluate the kurtosis. Excess kurtosis is positive. We had three types of kurtosis. L, MP. If you recollect, I asked you to acronym to, I mean, remember this. So
Yeah.
L is
Flat.
leptokurtic.
Hmm.
It has a positive excess kurtosis.
Hmm.
This is zero kurtosis, normal distribution. This is negative excess kurtosis. So let me write excess kurtosis just to avoid confusion.
Sure.
So now we have positive excess kurtosis. Which type of distribution?
Right side positive. Positive tile.
Yeah, and we call that as a leptokurtic L.
Yeah. Leptokurtic. Yeah. Leptokurtic.
Yeah. So I think the eligible answers are A
Lepto
and D.
and D. Correct. Yeah.
Now
So she
let's
also finds that based on this memory, correct distribution. Okay. Leptokurtic. And next is skewness.
hmm.
Hmm. Okay.
Now
Here.
if you remember,
Hmm.
I told you one picture. Can you help me? So if I tell you, this is my just for understanding first, then we will fit in this into our example. So say for example, my distribution is like this. Say it is right there. Can you tell me how is uh
So
so if I
mean. So this is
if
yeah.
I tell you three points A, B, C.
Okay.
So yeah, what would
Uh,
be A, B? See, midpoint is already median. So median already between two. So B is, let me tell you B, the simpler one. Difficult ones, you have to tell me. What should be A and C?
okay. Got it. Got it. So this one is on the symmetricity, correct?
Yeah,
Okay. Here. So
I told you one
so
important
this
point.
yeah, you told me the mean should be always on the side which is which is
Perfect.
greater, right? So I'm
Perfect.
trying to find out here. So in this case, how the only I mean here C will be the mean. Okay.
Yes, perfect.
C
Yeah,
is the
I'm
mean.
now okay,
That is
perfect.
clear.
Yeah,
The only
perfect.
problem I have is how did you draw this instead of a normal distribution? How did you draw it as skewed on the right hand side?
Yeah, this was just a general example. Now we can try
Oh,
evaluating if
general
this is
example.
a, yeah,
Okay, I was trying
just
to
to
think.
recollecting.
Yeah,
No, no.
yeah,
Let's now try to understand. Let me just write mu as a mu bar and like median and mode. Then we will see that if it is a how
understood.
the situation is for this thing mu,
So
median,
median
and
is 4.2 and 3.7 percentage and 4.8 percentage.
so mu is
4.8 is the side mean and this one is 3.7 is in the okay. Median is
okay. I think I am
you
wrong.
missed it. Yeah, you made 4.8 is the mean. Mu bar is 4.8. Median is 4.2 and mode is 3.7.
Okay, so median is 4.2%,
Correct.
and your mean is 4.8%, and your mode is
3.7.
3.7%. Now tell me what you think.
Hmm.
Does it fit in our arbitrary example that I take
Eh,
already took? Yeah.
Yeah, that's what I'm thinking also, because here, if you see median is 4.2, which is middle,
Mm,
and mean is on the right hand side, which is higher,
mm,
4.8, because
mm,
twisted on the right hand side,
mm.
and mode is 3.7, which is on the left, right?
Yep,
So this should be a positive leptokartic.
absolutely. So correct answer in this case is A. The
Yeah,
answer is A.
the reason why we call it as okay, now the reason why we call it as leptokartic is excess kurtosis of S2,
Yeah,
right?
it's positive.
Division positive. If
Positive.
it's negative, how do they say excess? And if it's negative, what will they say?
They will say like something -2.
-2 itself.
Yeah.
So okay, okay,
Yeah.
okay.
So this is something what we already discussed. Correct answer is A.
Okay.
And I think answer is maybe mistakenly answer is already given, but yeah, you can just all of the following statements are true except if the return distribution of two investment have the same mean and standard deviation, one of which has a more negatively skewed distribution will be considered as a riskier. I think you mentioned it to me
Mm,
when
it
you were
is true.
explaining. You read
The
it. So
tail,
this is
when you
yeah,
two and the tail is that, then it's riskier. Yeah,
yeah, negative skewed. That means that tail is
big, heavy,
fatter, yeah,
fatter.
heavier there, yeah, fatter, heavier. So
Even
it is
positive also, it's still a risk, right?
positive. Like see, yeah, in a way, see, if your chance of getting higher returns
Understood. Got it.
is more,
Understood.
so you can
Positive.
say that it's
So when
good.
you say negatively skewed, it means
L-
negatively skewed. It's on the left hand side. Moving
Like say
to the
for
left.
example,
Yes, understood. I think that's what I was thinking
if
as
if
well.
if someone tells you that
Lot of
probability of
items on the
getting
left. Perfect.
yeah -20% is higher, then
Yeah,
like it's like riskier investment.
understood. Perfect. Okay. Distribution of
Distribution, yeah,
positive
go on.
excess kurtosis is known as leptokartic. This is where I need to keep on reminding. So leptokartic, fatter tail, positive, right? Thinner tail, plateokartic, negative.
Yeah,
Okay.
perfect. Yeah.
Lepto positive. Okay. If two investment have the same mean standard in skewness, then the one with lower kurtosis will be considered riskier. Two investment with the same mean standard deviation and skewness, the one with the lower kurtosis. Lower
This is
kurtosis.
lower kurtosis. This is a lower kurtosis. A
Higher,
thinner tail.
yeah,
Thin.
higher kurtosis is usually considered riskier, correct?
Yes, correct. So because it will look like something similar to this.
Higher. This one is
Thinner,
thinner.
thinner trails. Yeah. So in these questions, we have given lower kurtosis.
Hmm.
So lower kurtosis is something this one, which is just tails are not even existing after certain point. So it is like it has certain thing till here only. So these are less riskier. So this is incorrect.
Sorry, can you repeat?
So
Uh, which one is the lower here?
lower here is like this one,
Got it.
platykurtic.
So when you say lower kurtosis, the height, they are looking at the height.
See, that's where the most of the people get confused. Just look in context of tails only. Forget
Hmm.
about peakness is something which I think essentially it is true. But yeah,
Oh,
when you are making a decision in context of riskierness, just focus on the tails. So the one that is leptokurtic has a fat tails
okay,
and normal anyways we are clear. Let me talk about platykurtic. Platy has thin tails.
okay, okay.
Okay. So that's why this C statement is incorrect. And the normal distribution has a kurtosis of 3. This is correct.
So this is basically lower kurtosis means thin
Yeah.
tails.
Yeah.
Okay, so many names are thin,
Yeah.
platykurtic.
But if your
Okay,
intuition, like if you solve 2, 3 more questions,
problems.
then it
Mhm.
will fit your muscle memory. It should get
Yeah,
through. Not an issue. Absolutely. Yeah.
normal distribution is a kurtosis of 3.
So it is
Yeah,
correct. And when
correct.
I say if I were to make this statement D in terms of x is equal to 6, then tell me what should have been a statement.
Come again.
If I were to make this statement D in terms of x is kurtosis instead of just kurtosis, then what should have been the statement? Just out of interest, I'm just trying to explore.
Excess kurtosis is positive, right?
Like for normal distribution, if I were
Oh,
to make a same statement instead of using kurtosis, if I have to use excess kurtosis in this line, what should be the another change should be made?
so normal distribution has a kurtosis of more than 3,
Uh,
greater than 3. No.
if normal distribution has an excess kurtosis of 0, because excess kurtosis is kurtosis minus 3.
K minus 3, correct.
So if I normal distribution, if I put 3, so
E-
so if I replace this term by excess kurtosis, then I had to replace 3 by 0. That's what I was asking. Like normal distribution has an excess kurtosis of 0.
Oh, that is also correct.
Yeah, absolutely.
Hmm.
Excess could like this statement has been made using kurtosis, but if I were to reframe this in terms of, see, it's kind of like negating or affirmation, like just playing around with words sometimes.
Words.
Yeah.
Okay.
So if I were to make this statement excess kurtosis, it is a 0.
Okay.
Okay.
Okay. Okay. Okay. Okay. Okay.
Yeah.
Because K minus 3 is equal to 0.
Yeah.
Excess kurtosis. Okay. Normal distribution has an excess kurtosis of 0, or
Yes.
normal distribution has a kurtosis of 3.
3. Yeah. So
Okay.
just focus what has been given to you. If
Hmm.
it is given, say for example, uh, if I tell you, if I don't change 3, okay, if I write the normal distribution as a excess kurtosis of 3, is it true?
Yeah, normal distribution has excess kurtosis of 3.
3.
Yeah.
Excess
No,
kurtosis of
0.
0. So just be very careful. Small tweak in the question
Hmm.
can like change
Confuse.
the true or false.
Okay, got it.
So that's why just be careful what is given. Is it a kurtosis or excess kurtosis? So if it
Oh,
is a kurtosis, just forget this K, just focus on only K. But if it
okay,
is given excess kurtosis, be focused on K minus 3. Think in terms of K minus 3.
okay, okay,
Very linear things, not absolutely no quadratic or exponents, but just be careful with terminologies.
okay.
Yeah.
Got it, got it, got it.
If I give you more, say, if I give you some example, say, leptokurtic, we may not get a good, normal distribution was a good example. Leptokurtic has an excess kurtosis of 0. Is it true or false? This is
Uh,
straightforward.
leptokurtic is positive, right? Positive.
Excess kurtosis. If I, yeah, in general, it is true. It is like this would be some positive number. This K minus 3 would be like,
Positive number.
yeah, for excess, for normal distribution, it is 0. For
Understood.
normal, it is
For
0. For leptokurtic, it is positive.
okay, and for
Let D, it is negative.
okay,
So just remember, if you are looking at in terms of excess kurtosis, but when you are looking in context of just kurtosis, just focus on K.
understood. In simple terms, normal distribution EK equal to 0. In case of
Normal
leptokurtic,
distribution, can you repeat? Yeah, can you
in
repeat?
case of normal distribution,
Hmm.
excess kurtosis is equal to 0.
Perfect. Yeah.
Okay. In case of leptokurtic, EK is positive because it will shift onto the right hand side, the tail,
Hmm.
right? In case of negative, that is platykurtic, it will be EK will be negative.
Yes.
Okay.
Yeah. Excess kurtosis. Yeah. EK. Correct. Yeah. EK. Correct.
Yeah, yeah. So I think I just put EK equal to 0, EK equal to positive, EK equal to negative, and I know EK equal to K minus 3.
Perfect.
Based
Perfect.
on this,
Sorted.
then I'll play.
Yeah.
Based on
Correct.
this, I'll play.
Yeah. So you have 3 rules. Just according to question, you can just try to fit where it exactly fits in.
Yeah, yeah, that should be fine.
Okay. So let's move. This is bit of computational, but yeah, usually it is not us, but some sort of insight it will get you. Perhaps the
Hmm.
last question, I think. Yeah. So bond has a default probability of 5%, which is the nearest. Now tell me, I mean, see, sometimes you know the formula
Application is
or
the
skewness.
difficult thing.
Yeah. So you know the skewness. Now tell me
Yeah.
how should like you're just given that probability of this is 5%.
So probability of default is 5%. It means it's on the right hand side tail. So it's a positive skew.
Oh, I mean, fine. We can have a look after drawing distribution.
Okay.
But
Okay.
you are see everything is positive. Like one is only zero. Rest all
Mm.
three are positive
Oh
numbers.
yeah.
So still
Yeah.
75% out of 75% we have to spot right answer.
Correct. Correct.
So
So which is nearest respect to the skew and kurtosis of the distribution? So
yes,
now when you say that now how do I calculate it? That's the biggest question.
yeah, exactly. That's
Because
where yeah.
yeah, because if you see right, we said the formula for calculating the skew and k is what is that
Hmm.
mu
Let me
the
let me just write it for you. We will try to. Can you just give me a moment? I'm getting a call. Just give
sure
me a
sure
moment.
yeah
Yeah. Can you tell
yeah
me what is the formula for, say, skewness, what we saw? I'll try to
yeah
explore from it.
skewness, the formula that I remember is xi minus the mu, the mean, the power of 3 divided by n minus 1.
X
Correct?
minus mu
Yeah,
over 3
by n
divided
minus 1.
n minus 1, of course, summation.
Summation, yeah, summation.
Kurtosis
Similar mind by 4, the power of 4 divided by n minus 1.
x minus mu over 4 divided by n
N
minus
minus
1.
1.
No,
But
see,
here,
just yeah, just if I try to calculate, say now over here there are no data points, but
yeah, no data points.
we are given a probability. So like how we had here, like when we were looking at covariance, so we had sometimes we are given data in context of expectation. So same is the case over here.
Hmm.
So when I talk, if I try to write this, so it is kind of expectation. So n minus 1 is expectation of x minus mu
Yeah,
cube.
cube
So what is
by
the expectation of x minus mu cube? Okay. Understand, I mean, we'll try to explore, but yeah, this is how it can be written. In a similar way, I can write what is the expectation of x minus mu to the power 4.
4.
Yeah. Now let's try to understand bit more. See, I'll tell you. I mean, this I deliberately put it to nowadays the GARP, how the GARP is testing. Earlier, the pattern of GARP was something this like more calculation oriented, how much formula you have understood. Now it's like more application based. Now they can give you this time. Now, like the pattern of the testing has changed. That's what the observation is from the feedback from the students. So like there it's like less of calculation and more of your application. But yeah, I mean it's good to understand these aspects also. I mean I know like it will give you curiosity that how
Mm.
just with this information I can calculate skewness and kurtosis. Let's
Correct.
see. So if I just calculate, so this is something I mean we this is a formula, but now say uh either it will default
Mm.
or it will survive. Okay,
Correct.
this is my these are the two values x can take. Okay,
Yeah.
so when I say like yesterday's, I think you watched the video, some context from there, like over here we just have one bond. So default has a probability of 5%.
0.05. Yeah. Point. 0.05.
0.05.
Yeah, and then 0.95 the success.
0.95 is success. If I talk, if I'm just referring to default as 1, like if I default as 1 and
0.
x is 0, can I calculate the expected value? So like if I talk about this, I want to calculate the like distance from mean. So I need a mu. So when I talk about mu here, it is a expected value.
Yeah.
Expected value of x. So when I talk about expected value of s, it's like this is my variable 1 and 0. Getting 1 as a 5%. So 1 into 5%
Yeah.
plus 0 into 95%. Eventually, I'm trying to say my expected value, that is probability of default, is 5% only. Now
Yeah.
what I'll do, I'll try to calculate this x minus mu and I'll try to attach with a probability. So when I talk about skewness, I can calculate it as 0.05. So this x is 1,
Mm.
1 minus my, this thing is, the mu is 0.05 q,
Mm.
and probability of getting this is 0.05. This is eventually 0. This term will anyways vanish. So no need to write that. It's in a similar way.
So one
Yeah.
second here, x minus x cube into 0.05. That's expected value. Huh?
Yeah. X, because of expected values kind of weights, like how I attach 0.05 and 0.95.
Mm.
Similar way, I would, if I were to write it completely, let me just write it some, because it's summation or expected value, I can write it as 1 minus 0.95,
Cube into 0.95.
0.5 cube into
0.095.
0.095. Okay. In a similar way, can you tell, I mean, you can always calculate this, but yeah, main purpose was writing this expression. In a similar way, when you talk about kurtosis, it will be 1 minus 5% to the power 4 into
0.05.
probability is 5%, 1 minus 0.95 into
Actually,
0.95. So this, sorry.
sorry. Oh, that is x is 0, right? Second one. 1 minus 0.105 or 0 minus
Yeah, I
0.105.
think 0. Yeah, 0 minus testing and yeah.
0 minus mu is 0.05, correct?
Yeah, my bad. Sorry.
Yeah, and times the expected value, which
Value.
is
Yeah, 0 minus
0.9.
5% to the power 3, 0 minus 5% to the power 4.
Okay,
So x minus mu cube and
okay.
4th power. This is something which one can calculate. Let me just check if the same thing. So far we are correct here.
Yeah.
So third central movement 1 minus 0.5. Yes, absolutely whatever we have done. So probability 5%, 95%. So 5% and 95%, absolutely. Same way, you can just calculate. You will get third movement as 4.12 and kurtosis as 15. So kurtosis as 18.
Yeah.
So when you calculate this kurtosis in the same way, you have kurtosis, but if you subtract 3, excess
Excess kurtosis.
kurtosis would be 15. So, but in question we are asked to, we are
Kurtosis.
given kurtosis, so we will mark this as an answer. So answer
Okay.
is C.
Okay. Okay.
So this is how you can explore. Of course, this
Mm.
will give you a good understanding. If you are not given very less information also, you can explore.
But in general, they give the random variables
Yeah,
most like.
usually see like mostly like their testing would be on this area, like how your visualization is on the data. Because see, lot of practically speaking, there are a lot of softwares available to
Yeah,
get you the
calculation.
data, but how well you interpret that data and make decisions as a risk manager is
Mm.
something which FRM tries to build in you.
Okay.
Yeah. So this what we had for today's session. So with
Okay.
this we covered the sample moments. So I mean, yeah, I was just asked to check with you. This is something we had for you. So
Mhm.
just think and come back to us, our team, if you find that quants can be covered in short span of time given you have constraint. So if
Mhm.
you think that it can be value adding for you in
Mhm.
any context in
So
short
the
span
thing
of
is
time.
like
Yeah.
how much you can cover if I want to pay this amount, right? Whether you'll be able to cover the entire quants and how long will it take? Do you think um, you've seen me in action now?
Mm.
Um, but again, there are so many other things that I do not know. That's a problem.
Mm-hmm. See, you might have seen there will be a lot of more stuff in your chapter when you will go through books. But trust me, whatever I taught you will be sufficient for your exam. That's based on the experience we have. So in a similar way, we can get you to the level for quants. And to answer your question, if you just want only on weekends, we
No,
can
I
do
can do daily.
daily. But daily at what time? Because even we need to figure it out. But
What time is comfortable for you?
we can take that offline. I'll just get in touch with you
See,
over
thing
WhatsApp.
is like usually I'm available after 4:30 India time.
Hmm.
Would
And
that work?
early morning, like early morning, what hours?
Early morning is difficult
Hmm.
because I need to go to office 9 o'clock Singapore time. That's 6:30
Hmm.
India time.
Hmm. Let's figure it out. Yeah, I see your point. I'll
What is
give you.
your recommendation? What is your preference?
See, I'll give you call on WhatsApp after
Mhm.
this meeting
Oh,
only.
okay,
So we
okay.
can we
Let's say
can
call me,
connect.
call me.
Yeah,
Yeah.
yeah. So just consider this, but yeah, it will definitely. I mean, like these kind of three questions. If you solve, like, if I say good, see, I we prefer quality over quantity.
Hmm.
So if I talk about 10 questions per chapter of
Mm.
very good quality,
Yeah.
so like 100 students also can get you in a good position. That's what we believe. See, I mean, if I solve 1,000 questions, still I'm
Mm.
not able to build that intuition or that kind of a thought process flow. It doesn't creates a value. But yeah, on the
Okay.
other side, we believe that quality is
Yeah.
something we can build in you and get you a good thought process would definitely will help you.
Sure.
So
Just call me on the mobile. I'll because I need to understand how we can make this work.
sure thing, will do.
Okay.
Give me
Okay.
time, I'll call you. Yeah.
Okay. You call me now or
I mean, I'll
uh,
call you right after the call.
yeah,
So
right after the call. That would be
yeah.
good.
Yeah. Good.
Okay. All right.
Yeah.
Thanks.
Thank
Thank
you.
you.
Have a good day. Yeah.
Thanks. Bye. Bye.